Right now, a star is dying so violently that it could sterilize an entire galaxy, and you need to know if we're next. Imagine an explosion so powerful that in just 10 seconds, it releases more energy than our sun will produce in its entire 10 billion year lifetime. This isn't science fiction. This is a hypernova, and it's the most catastrophic event in the known universe. But here's what makes your heart skip a beat. These cosmic monsters don't just explode. They shoot beams of destruction across space that can kill from thousands of light years away. So, what exactly is a hypernova? Think of the biggest supernova you've ever heard about and multiply its power by 100 times. When certain massive stars die, they don't just go out with a bang. They go out with an apocalypse. We're talking about stars that are at least 30 times more massive than our sun. These stellar giants live fast and die violently, and when they finally run out of fuel, their deaths reshape entire regions of space. Here's where it gets absolutely mind-blowing. The core of these massive stars collapses in less than a second. In that brief moment, gravity becomes so overwhelming that the entire center of the star gets crushed into something incredibly dense. Sometimes it forms a neutron star, but in the most extreme cases, it creates a black hole right there in the heart of the dying star. The outer layers of the star then crash down onto this newborn cosmic monster at speeds approaching a quarter of the speed of light. But the universe isn't done with its spectacular show yet. As all that stellar material spirals inward, it heats up to temperatures that make the surface of the sun look cold. We're talking about temperatures reaching trillions of degrees. The intense magnetic fields generated during this collapse twist and amplify, becoming more powerful than anything we can create on Earth. These fields channel the explosion's energy into two narrow jets that blast out from the poles of the dying star at nearly the speed of light. This is where hypernovae become gamma-ray bursts, and this is where things get truly terrifying. These jets are like cosmic blowtorches that cut through space, carrying more concentrated energy than anything else in the universe. When one of these jets points toward Earth, even from halfway across the universe, our satellites detect it. These are gamma-ray bursts, or GRBs, and they're the brightest electromagnetic events known to occur in the cosmos. Let me put this in perspective for you. A gamma-ray burst releases more energy in 10 seconds than our sun will release in its entire lifetime. If you could somehow capture all that energy, you could power every city on Earth for trillions of years. But here's the scary part. If a gamma-ray burst went off close enough to Earth, and one of those jets pointed directly at us, it could be an extinction-level event. The gamma rays would strip away our ozone layer in seconds. Without that protective shield, the sun's ultraviolet radiation would sterilize the surface of our planet.
Phytoplankton in the oceans would die. Plants on land would wither. The entire food chain would collapse from the bottom up. Some scientists believe that a gamma-ray burst might have caused one of Earth's mass extinctions hundreds of millions of years ago. But before you start building an underground bunker, let me share some good news. For a gamma-ray burst to seriously harm Earth, it would need to occur within a few thousand light-years of us, and the jet would need to point directly at our planet. The universe is incredibly vast, and these jets are extremely narrow, covering less than 1% of the sky. The odds of this happening in our cosmic neighborhood during human existence are incredibly small. Still, astronomers are watching. We've detected thousands of gamma-ray bursts since we first discovered them, and every single one has come from distant galaxies billions of light-years away. Each burst tells us about the violent deaths of massive stars in the early universe, giving us a window into cosmic history. Some bursts last just milliseconds, while others continue for minutes, painting the sky with high-energy radiation. What makes hypernovae and gamma-ray bursts even more fascinating is what they leave behind. After the explosion fades away, we're often left with a rapidly spinning neutron star called a magnetar, or a black hole surrounded by a disk of superheated material. These remnants are cosmic laboratories where physics gets pushed to its extremes.
Absolute limits. Matter gets compressed beyond anything we can achieve in our laboratories. Time itself behaves strangely near these objects, following Einstein's predictions about gravity's effect on space-time. The jets from these explosions also forge some of the heaviest elements in the universe. Gold, platinum, and uranium are all born in these extreme conditions. The ring on your finger or the platinum in your car's catalytic converter came from stellar explosions billions of years ago. We're literally made of stardust from these cosmic catastrophes. Scientists are now discovering that gamma-ray bursts might come in different varieties. Some are caused by hypernovae, as we've discussed, but others might result from colliding neutron stars or a neutron star being swallowed by a black hole. Each scenario produces slightly different characteristics in the burst we detect, helping astronomers piece together the story of what happened billions of light years away. The detection of gamma-ray bursts has revolutionized our understanding of the universe. These explosions act like beacons, shining across cosmic distances, allowing us to study the universe when it was young. Some bursts come from so far away that their light has traveled for over 13 billion years. We're literally watching the deaths of stars that exploded when the universe was just a fraction of its current age. Modern telescopes and satellites work together to catch these fleeting events. When a gamma-ray burst occurs, space-based detectors immediately alert ground-based telescopes that swing into action within seconds. They capture the afterglow of the explosion as it fades over hours and days, revealing details about the dying star and its environment.
So, are we in danger? The closest star that could potentially produce a gamma-ray burst is far enough away that even if it exploded tomorrow and aimed directly at us, the worst we'd experience is a spectacular light show. Our atmosphere would absorb most of the radiation and life would continue. The universe is dangerous, but it's also vast enough that we have breathing room. Hypernovae and gamma-ray bursts remind us that we live in a dynamic, violent universe where stars are born and die in spectacular fashion. These explosions help create the elements necessary for life, seed new star formation, and shape the structure of galaxies. They're not just destructive forces, but creative ones, recycling stellar material into new generations of stars and planets. The next time you look up at the night sky, remember that somewhere out there, right now, a massive star is in its final moments before becoming a hypernova. Its death will light up the cosmos, releasing more power than 1 billion suns and forging elements that might one day become part of a distant world. The universe's most powerful explosions aren't just cosmic curiosities. They're fundamental to the story of how we came to exist in this vast, spectacular cosmos.